Hello. Today we will do some coding. We will do a code editor in Zig. Zig is a wonderful language, a beta C, and I think it's a perfect choice for a code editor. So let's begin. We will call our editor Kisa. I have made it up just before the recording, so let's start with creating a directory and Zig. What do? Zig init exe because it will be an executable. All right, we will have everything. So let's try to run it. Okay, takes a while for the first time. All your code base belong to us. Well, seems like it's working. Okay, so let's also init a Git repository. And what do we have here? Zig cache out. We probably don't want these cache and out directories. Let's create a git ignore. Zig cache and zig out. Yeah, that seems right. Okay. Let's create our first commit. Beautiful. So we will do a terminal one, and I have recently ported the new courses library to Zig. Not all of it, but enough to get started. So let's add it as a submodule. I know in Zig there are some package module systems, two kind of popular, but still there is no official because it is not the priority, but it will be soon. The language is pre 1.0 version. So let's just import it as a submodule for now, okay? So yeah, I checked whether this name was already taken by someone, and seems like career and some kind of political stuff, nothing in the technology land. Okay, so it should be somewhere here. Let me repositories. No, yeah, this one. So we have a code, and I also opened submodules because I don't really remember how to do that every time. Git submodule add. Git submodule add. So this should add everything if I'm right. Diff blah blah blah. And then yeah, we just yeah, okay. Yeah, we should be good. We clone in the library and it's done. Let's see what we have. Yeah, seems okay. Let's commit. Add Zig new courses. Now let's start with something simple. As a code editor, we will need to read a file and display it on the terminal. We will not use GUI like GTK or something native like Cocoa or macOS. Let's just use terminal because I like terminals, and I think that the best way to do good stuff is to do it for yourself. So let's begin with yeah, let's read the file. In Zig, reading files is a bit harder than your average program, so I will refer to my previous work. I did Rosetta challenges for a compiler, and there are a lot of examples how to read the code or the code, read the file from std in and as a parameter as a first argument. Yeah, somewhere here. Yeah, I think this should do it. Okay, and let's get through the code. First, we initialize allocator, then we defer to the init. This is arena allocator. In Zig, memory management is rather explicit. And arena allocator is just something that you initialize once and you de-initialize it at the very end of the program. So it should be good for now. I don't know which memory management we should use here. Maybe we should go with a general purpose allocator like malloc or something like that, but let's do this for now. So I also saw that alley is a better name for allocator because allocator is very long to write. Let's use alley. So we here get our arguments. This is, we get an iterator, iterated once, and get a program name, and it shouldn't really fail, or rather return nil. So we use or else. Then we get the file name, and we see that if we have a file name, meaning that we have the very first parameter, we get the string of it, and if don't, we are waiting for standard input, right? Yeah, this seems all right. And we also close it at the very end. Now we try to allocate all the memory read to and alloc. Do we have something like read all without this thing? Here we specify the length we want to read, and now we want to read just all the file. Let's go to the Zig code itself. It's very easy to browse Zig code. It's very understandable, at least for me. But I think for everyone it should be kind of bearable. I think bearable. So let's use this file handle. It is, what do we need to do? Okay, it's open file cd fs. Let's go to fs of file. We have a file, I think. Can we read it? Okay, read file sig by sig2. Maybe we should also read to end alloc. Yeah, this is what I'm using. Read to end alloc options. Okay, what else? Read to the buffer. Read all, but also a buffer. We don't have a buffer, right? We want to read everything at once. P read all. What is P read? So it is with an offset. Read V. It's from IOVec, whatever it is. And yeah, I think we chose the best option here. So let's call it input content, maybe just content, right? And let's make sure that everything works by printing it out. Content. So now we will need some file. Well, we can as well use this file, same file, zig build run.zig. Zig build run. Cannot run step. I don't want a step. We need to give it as an argument to the function. Okay, we changed it to alley. Let's change it here too. Okay, here too. Let's go. and written. Yeah, I need to learn how to write. All right, we have it. We have successfully read a file. Yeah, we can give ourselves a bit of clapping. Let's commit, read and output a file. And we also can do it via standard input. I think it is done like this, right? Main.zig. Yeah, or with utility with a Unix pipe. Let's try that. Main.zig, zig build run. Yep, works. And if we run just zig build run, it will wait for a standard input. We can write something, and then press Control D for the end of input, and it will print same thing, right? Here, here, yeah. Okay, so now we have a file. So let's display it in the new curses context, right? We want to do some new curses processing. So let's first display it not on this terminal, like I use Kitty as a terminal. And what we do here is we display it inside Kitty. What I want to do is to initialize new curses and display it in the overlay over Kitty. So let's first add our library. We have here, where do we have it? Zig and curses. It's with Zig cache and Zig out invisible. We need to go to build.zig. Yeah, our build.zig. Let's remove these comments. Let's add our library. So let's search for an example. I should have several examples of, yep. So exe, yep. Let's use that. Add package path. Do we maybe here add executable after add executable? Yeah, we can do it here. So we will add new curses, and it will be at the root zig new curses / lib.zig. Okay, so it should add it with an alias new curses. And let's get back to main and try to use it. We'll use using namespace, so all the symbols are readily accessible without the need to fully qualify them with the namespace. Import new curses, and let's get new curses hello world program in the examples. Is it here? Yeah. So after we have read the file, we should also, I think, start doing it in functions. Yeah, I think we should do it in functions so that we can structure it a bit better later on. So let's put file reading into a function, and we'll call it read input. Sounds right. Read input. It will take an alley, which is allocator, a pointer to allocator, and that's all. It will return. What is it going to return? Yeah, it will just return a slice. Okay, and I think we can do it like this. Yep. Here we will need content, const content equals try read input. We use try because this can fail. Every time we use try means we can fail, and we put an exclamation mark to signify that this function can possibly fail. Okay, here we will just return. Oops. So this should return a slice, as I understand. Read to end alloc. Let's find it one more time. Yeah, it returns a slice. Is there some implications like return to owned slice or something like that? Probably not. It just allocates some memory and we should be fine. Yeah, we should be fine. So we will get a slice, basically a string, and we will be responsible for freeing its memory. Let's just supply an allocator. All right. So is it going to work? Okay. Okay. Good. Good. It also took a while because we included new curses, which also includes a C library and translation of new curses header, which I have on my system. Right, I have this new curses installed and a header file too. Previously, I spent some time maybe translating half of it, maybe a third of it. But a lot, all the essential stuff is there. So let's commit, put input reading into a separate function. Seems okay. Now we should initialize our new curses context. Okay, so we got our content, and now instead of using cd-debug print, we will do it with new curses. Initialize screen, we deinitialize it at the very end, and then we try to print something. So we do try print wzig. This will print to the screen where our cursor is at, and it will be the very first position, the upper left corner, if I'm right. So we'll need to print a string, and let's pass it as an argument. Now this actually prints to a virtual screen, and we will need to move it to the real screen so we see it, and we do it with a refresh command. And this is how we stall the screen. We ask to read one character. So we ask to read one character, and if everything goes, if when I press it, only then the program exits. We don't want it to exit prematurely. Okay, let's try it. Okay, use of undeclared identifier. Okay, so this means that we probably either mistyped. Let's try to copy it here. Yeah, nothing changed. It means that we don't import the correct stuff. This is lib.zig. Oh, right, we still have separate namespaces for C and new curses. So we need to write here new curses, like so. All right, these are different errors, which is great. C import failed. libc header not available. Okay, so I suppose it means that we need to link against libc. It's a bit strange because in the library we already do that. So do we need to re-import the C stuff? Okay, let's try just linking with the C library. So we also have it in Zig. I mean new curses. So we have link system library, link libc. So yeah, maybe we need this because we don't really link anything, right? Let's do that. And not examples, but exe. Okay, how about now? The moment of truth. Okay. It says resize fn, and as I understand, we use this main. We use arena allocator, and if I remember correctly, resize fn does not implement, arena allocator does not implement resize fn. So maybe we can check it. Arena. And what about resize fn? Resize. Well, we have resize, so maybe it's not the problem. Okay, let's try again. Let's try like this. I like this more. Okay, so maybe the problem is that we didn't close standard input, because this one works, but it doesn't work with standard input. Okay, so I don't know what's the reason exactly. I will just add a to-do here, or as a fix me, set in logs new curses. Yeah, something like that. But now, see, we have, yeah. And how fast is it? Out Kisa. It expects file name. Yeah, pretty good. Zig build run. I'll forget. Is this fast? Oops. Yeah, pretty fast. 5 milliseconds to read the file. Okay, so let's not get to let's not try to prematurely optimize anything. So now we have something working. Let's commit what we have. Display the file content in the cursor's context. So, okay, we have our file displayed. Now, what do we want to add? Maybe we want some abstraction to display the line count. So at the very top, we want to have 1, 2, 3, 4, 5, and to the bottom. Yeah, let's try doing that. I think the correct way would be to have an abstraction around the content, and we will have a line iterator that will give us a line. So we will put a number and then print the line. Okay, let's do that. So we will create a struct. Yeah. And let's do it pub. Let's do everything pub because okay, let's not run ahead of ourselves. We'll have a buffer. We'll have a buffer for each file, and we should also have a virtual buffer for not yet saved for windows or views to the text which are not mapped to the files on the file system. For now we can call it a buffer, I think. Well, let's do that. It will be a struct. It will have an allocator, and it will have yes, content. How do we call it exactly? Yeah, just content. Will be U8. We don't want to make it constant because we will likely modify it in the future. So let's just sketch a general interface for that. Public function. Okay, public buffer. And we will do a next line. It will return a line. We also want to keep the line numberings inside the buffer, or do we want to have a separate struct that will manage this abstraction? So here we will return a constant U8 string, and we also have the split iterator in the standard library already, which does exactly that. Split iterator. It splits the line, and it has a next function which outputs something. Yep, exactly that. So we have a pretty good library for that. Let's use that. We'll have this line it. It will be a line iterator, split iterator. So we use a lot of std_mem. Maybe we should write it here, or maybe not. Okay, we need to initialize buffer at first. Init, we will give it content, which is U8. So we would like to copy it to take ownership of it, as I understand. Okay, we will get a buffer. Yep. a buffer. Now we will return buffer. Alley is allocator that we will receive. Yeah, here we need to write equals. Content is content, and line iterator is our std_mem split. Okay. std_mem split content, and we need a delimiter, which is a string. Okay, so a new line. We'll use the Unix one. For now, maybe we will add this /r/n Windows stuff, DOS, but I also read that it is somewhat complicated, so let's not do that now. Okay, so we're generally fine. But this line, yeah, we want to actually duplicate it because we want to take ownership. There should be a dupe function, something like that. Maybe an allocator, dupe. Yep. Caller owns the memory. Okay. Looks right. So let's use it. We should do this self allocator. Yep. So let's do it. Let's do alley.dupe. And we duplicate. We should put a type. And we put a same constant type. So this should work. Now we try. Should use try here. And if we are at that, let's also create an error union. In Zig we use error unions to indicate which errors are available or as allowed, which errors functions are allowed to emit for better error control. And I know that this allocator stuff usually produces out of memory error. Is this right? Error, yep, out of memory, a single one. So far, this is a single error that can be produced. Buffer error, and next line. Yeah, I think we should be safe here without any errors. And it should be just same interface as our split iterator, like so. Okay. So let's try get our content, right? Then we initialize our buffer. Try, because it can return an error. Buffer.init alley content, and that's all. Now we want to print some stuff. Okay, so we want to iterate through buffer while it has at least some lines in it. We will do it with for loop. In Zig, it is very convenient to use this for loop like so. And if it returns non-null, we get our line. If it returns a null, it just ends. Like so. Now we will need to print a line, also add a new line because it is eaten by the split iterator. And we want to print a line number, right? So let's also add an index here. It will start with 0, and this means we should just add 1 to it. Let's print. Yeah, let's use same function for printing. I think it should be all right. IDX. Okay, so how are we doing? Expected 0, found 1. 4. Okay, so oh, I see. When we put functions inside the buffer, we should also put the self or some kind of the first argument, the buffer itself, and pass it as a pointer because we want to mutate its state. Currently, this line iterator is mutated. And this also lets us call it in this method call style, object.method. But it's not really a method if we are talking in Zig terms, just a function inside a struct. And use of undeclared identifier. Yeah, sure, we should reference it with self. Okay, expected type buffer, found const buffer. Yeah, we shouldn't declare it as a const. We will mutate it. And now expected type const u8 found. Okay, so I guess we should put u8 here. This is what the error says. Yeah. Yeah, let's try that. Does not support field access. 34. I do not understand this error completely. Maybe we can try it without index. Let's try to erase the index for now. Okay, it's not the problem with the index. So what's does not support field access? Do we do a field access anywhere? Do we do line dot something? Not really. So maybe 4 is not the right stuff for it. Okay, maybe we can go to our split iterator and see any examples of the for loop. Let's go to Zig Documentation. For loop. What can we do with for loop? Over slices and arrays. We don't need that. We need to determine whether it is a null value or an actual value of a portion of a slice. Traits slice by reference. Full loops as expressions. for items value, if value does not equal to null. Okay, so apparently we can't do that. Can we do it with while? While with optionals. Yeah, I think while is what we should use here. So we will have while. Okay. So print WZig out of memory. Index, try write, blah blah blah. So here we do some interfacing with C. This is why this error is unreadable. But we will have to read it. No other way. Okay, so let's start with something simple. Let's try to put a number here. Okay, we can do that. Maybe we can maybe it is too far of the screen. Maybe it's the number of lines are very low and it cannot print them. So 0, we can't print 0 one time. Maybe we print line too many times, so it goes beyond the bottom border of the screen. So if we, let's try to I equals 1, we also have, this is going to be our line count, right? We have this construct that we can do some stuff when iterating. Line count. We will do here line count, and we will break if line count equals 5, break. Must be const or comp time. Okay, maybe we should give it a type. Yeah, like that. 1, 2, 3, 4. Okay. Let's try with 10 maybe. It's 60 lines. Yeah. And we can see that 54 is the maximum. So let's try 54 lines. Okay, let's try 55 lines. Okay, 56. Yeah, it's too much to the bottom. Let's say it like this. So let's just print 30 lines. So it is conveniently, we can maybe 24. So it's half the screen. Okay, so on resize we still get an error because it cannot resize. Okay, so 24 is all right. Let's do it like this. Line count. All right. So we want to have a space, at least one. right? So it should be like here. And we also want to have the required space. So for example, we want this one to be 2 character wide, like 10. So it is aligned that we want to have this one to the left, yeah, like on this real editor, these lines are aligned to the right side, right? We want a similar effect. For that, we will need to count the largest number. We will probably need to do it for the screen, but now we can do it for the whole file first. Yeah, so it will no longer be a single pass. We won't be able to next line because first time we will need to do a pass of analyzing to get the maximum number. Okay, so how do we want to do it? We probably need a better abstraction as well for this. Let's let me think. We probably want to get a number of lines, like we want to get all the lines, then we want basically not to get an iterator style line by line, but we want to get all the lines we're going to show on the screen. Here we will have hard-coded 24. Let's also make it a constant, like max height 24. And we want to if we are going to have 24, then yeah, we still need to do that because I thought that we have 24, then 2 digits max, but we still can have only single digits, and we shouldn't switch any alignment with single digits. Okay, so let's count. We will do this counting, right? And then we will do printing after that. So let's try it the dumbest way possible. So here we want to count lines. Yeah, here we do same stuff. Line count equals 1. Line count equals 1. And we want to count the lines. So here our line count is actually going to be the desired amount of lines we want to count. So basically this is it. So now we should count how many characters in the number. Yeah, we should probably do it with a modular operation. Is this right? Yeah, probably right. Const max line count width. Yeah. And we do line count modulo. Is this how we do modulo in Zig? Module mod. Where is my cursor? I don't really see it. So hard to see. Yeah, here. Mod. Yep, here. Modulo, remainder, whatever. Yeah, I don't see it. Modulus division. Maybe we should use it is built-in functions. Maybe we should use that because it doesn't apparently have a percent operator. Remainder division. Well, it has. Okay. Oh, all right. I think we can do that. Let's use a normal modulo 10, and if we have 1, we're going to have like 1, 2, we'll have 1, 2. If we have 10, yeah, we'll need to do it in a loop, I think. Okay, let's do that. So initial size is 0. Now we will need to divide it line count. Yep. While line count is not equal to 0, and we will divide it by 10 every iteration. Max line count plus 1. Okay, we should get the max line count, and this is the number of digits that we want this is a number of characters that the space that we want to have for the line count. But here is another problem, that this should be compile times string. This is how it is implemented in Zig. So what we need to do, I think, is yeah, we should have something like this. We should have nothing aligned to the right, and here is our width. Maybe we can still, is this going to compile? -42. Let's also use U32. FMT 324 writer, call from here. Okay, if we do it like this. Yeah, if we do it like this, it is cool, but to do it in a different way. Int to string. Can we use int to string? It's not going to be comp time. Yeah, we'll have to emit some spaces, I believe, depending on the current width. Yeah, it doesn't seem very optimal, but maybe for 100 lines it should be okay, I guess. So let's put this stuff into a separate function. We'll call it number width. Yeah, and we get a number. Let's use U32. What is U32? So it's something like 2 to the 32. Yeah, this number looks pretty big. We should probably be safe that we're not going to have a file that has more lines than this number. Okay, how big is this file? going to be one character, and let's do for E in sec this, and we do echo I to many lines dot txt and something like that, right? Let's also time it. Okay, and while we are waiting, let's finish our function. Okay, we have var, and we say it is n. We have line count, which we don't want here exactly. U32. This is what you want to return from the function. Number width, line count. Fish too much data emitted by command substitution. Oh, I see. It tries to make this into a list, so it's all in the shell. We probably shouldn't do that. Let's okay, let's write a quick script. So we will need this number, and we will just need to do it that many times. Let's lines.name for I in 0. This number of times we will write to a file. So how do we write to a file? Write file, something like that. Name documentation. Searchable index, standard library. Yeah, right. F file IO. Just write. How do I open a file? Read bytes, write. Write file, I think should be. Yeah. This. Write file, and we want to append actually. Right, so we want to append to a file. So let's read and then append. Let's open it in file mode fm append and then read open. Okay, so we have open. Yeah, this one. It returns a file handle. Let's var f equals, this is IO functions should be imported. Open lines, many lines.txt. Yeah, and we should fm append. And now we do f write, and we also append this new line. So something is not right, probably because we don't need a dot here. And let's see what name is going to tell us. Type mismatch, got string, one of file, of size, fm read. Yeah, we don't need a set here. Yep. I use Nim because it's just very fast to write in this language, and it is a fast language. I know Ruby, but I think in Ruby this many lines is going to take a while. Even Nim doesn't do it as quickly as maybe we should just. Yeah, let's check. Do we have something in? Yeah, we already have a lot of stuff. Let's just compile it in release mode. It will do it much faster. So let's get back to the Nim program meanwhile. Result is n, result here, result is 0, and we also want to shadow this n. Let's use a full version of the name, and now use a short name. Okay, this sounds right, and we want to return a result. While n does not equal to 0, we will reduce it by one base, one base, or like one radix base, right? Dividing it by 10. We will have, for 1, we will have 1, for 0, we will have 0. -1 is not allowed because we have an unsigned type with this u prefix. Okay, so this should work. So we have max line count width. Now we should emit some number of characters, right? We should make a difference between our current line count and the max line count, and we should emit exactly that many. Okay, so let's do that. Max line count. Let's yeah, U32, we have it. Okay, minus line count. Hopefully it will iterate exactly that many times, but I'm not sure actually. Let me check. We already didn't use the for properly. Yeah, it doesn't seem like it's going to do that. Okay, so when we want to do something exactly n times, we can always use a while loop. While we will need to have some temporary variable, right? Let's do it in separate scope as well. Ri equals 0. Yeah? Or we want to have it like line count. Okay. While this is not 0. Oh, wait. We want to do it this many times. So max width minus number width line count. So we want to do to insert that many spaces. Okay, so this should be simpler now. Okay, while I does not equal to 0, we will increase I by 1, and we will insert one space. Try print or add ch, yes, this. Okay, so I think this is how it's going to be. We have our maximum, then we count what's the width of this number, and we do it exactly this time. Minus. Okay, so our Nim program takes a while. I guess the the maximum number of U32 takes a while to print. Let's span a new terminal. While go to Kisa and let's do that. So it does not look correct. So it doesn't add anything here, which is right, but it adds 2 spaces here, and we want it to add just a single space. So what could be the reason? So what is the I in this example? And by the way, I don't really know how to properly do debugging when developing new cursors, because this is actually capturing our whole terminal, and if we do some debug print or if we try to enter debugger like LLDB or GDB, it will interfere with the new cursors window, and I'm not yet sure how to properly address that and use it successfully. Okay, so here 1, 2, 3, 4, 5. Here's 5 spaces as well. So yeah, something is not right here. I think we have this hard-coded, and this is the reason. Let's try one time. Oh, yep, that looks fine. But we also have an empty line. Why do we have this? Why do we not start from the very beginning? This is our src main file, right? And we start from the line 25. Ah, I see. I guess here we already mutated the state of the iterator on this line. We want to reset it. Pub fn line reset self buffer. What's reset function? Probably reset. Next. No, but we should still be able to do something. I guess if we put index to 0, it is going to work. Okay, self dot line 8 dot index equals to 0 void. Okay, so we did some counting. Now we do cleanup, line reset. Okay, so yeah, we got our numbers here. So some progress. Let's commit that. Numbers are printed. All right. So we also have new files, many lines. Let's count many lines. How many lines do we have here? Oh, this is going to take a while too, I guess. Yeah, I didn't expect it to be such a big number. And we use this Cocoon editor. Let's see how it's going to act with this file. Oh, it just errors out. It cannot open it. File is too big. How big is it? Oh my, 46 gigabytes. Okay, I think U32 is an enough big number to um, represent the line count. Because if we are going to make it U64, which is the next logical number to do, it's going to be like U32 times U32, right? It means that we will have 46 gigabytes times 2 to the power of 32, which is I'm not sure how. Uh, okay, let's do that. Let's use Ruby. Let's use Ruby for that. We have 46 gigs. Now we will 2 to the 32. Okay, so now let's try to get how big it is going to be. So this is the number of gigs, right? So this is gigabytes, right? So then we can put like 0.5 and next one is terabytes, right? Then we can do it like this. This is going to be petabytes, right? Let's get some help with this metric stuff. Terabyte wiki. Maybe wiki is going to have metric of all the simple English. Byte wiki. Multiple byte. Yeah, here. Petabyte. All right. Then one. This was terabytes. Okay, gigabytes, terabytes, now petabytes, now exabytes. How do you exabytes? Yeah, EB, exabytes. So 197 exabytes. If we use U64 for line numbering. Okay, I think we should be okay. We should be okay. Yeah, let me try with a couple of other editors. We have AMP. Well, Cocoon just says that file is too big in debug. Let's try AMP. Is it going to crash? Place your bets. I think it's going to crash. Oh my! Let's look at this memory. Okay. Oh my god! It's going to end my stream, my recording. It's trying to open it. Read it all to the memory. Oh, yeah. Okay. Is going to kill everything I have? And my recording going to break? I'm getting scared. I'm pressing Control C. Please. Yeah, I want to kill this. Please. Yes. Okay. Polite quit request. Okay. I respect AMP for politely quitting. Okay, AMP didn't crash, but it tried to crash my system. So we have Vim and Vim. Yeah, let's install it. Okay, yep. We will also need, yeah, by the way, let me add these libraries. Do I have a list of all the libraries? Here I have some, yeah, I have them already. I have some overview, some ideas about what editor I'm going to do. So we have state-of-the-art terminal editor, NeoVim. How is it going to open it? Okay, watching at the memory here at the top. All right, it's growing. Okay. It's growing rather slowly. 11 gigabytes. 12. 14. Okay. A bit afraid. It's going to. I have never experienced out of memory killer, but please. System is still responsive. I guess it's just because not all CPUs are busy, but memory is quite high. We probably don't want that. Okay, tries to read it all too. Okay, can we kill it with Control C? Okay, so it's interesting, right? Because we tried to kill it with Control C, and it opened file in read-only mode with as many characters as it could. Let's switch to the very end. Yeah, so this is like a fourth, right? 1/4 of the lines, which is somewhat it consumed about 10 gigs of memory, which is logical because 46 gigabytes is the file size. Okay, I think this is smart, right? All right. We have yeah, it tries to deallocate memory, which is not very nice. Let's kill it. We're trying to be polite. Okay, let's be harsh. Yeah, forced quit, not polite. We're not going to be polite if the program misbehaves. Okay, so I have this. No, I don't have this. Let's try this. Yes, we should. Yeah, this terminal is kind of unresponsive now. Let's go Kisa. This editor. Oh, 2 words. Let's. Yep, this one. I installed them, but I deleted because I thought, oh, I wouldn't need them. Many lines. Oh, what? What? It opened? Oh, okay. Okay, not bad. My idea is that we can do that stuff too, you know, we can read the file, not read it entirely, just read it to display for the screen size. Yeah, we need to display just 25 lines here, just 25, and we can just read it sequentially, right? I think if we try to go to the very end, it's going to hang forever. I think Shift G does it. Oh, so it has also read at the end. Wow, that is very smart. This editor is like this like very cool. I've read on the wiki on GitHub, and it has some very nice thoughts about it. I really liked it. So we have our first winner for now. Let's also try. We have amp with micro. Let's try micro. I like micro for its insane mouse support. But oh, and it is in our terminal is broken. We don't have our cursor. Oh, oh, okay, okay. Let's kill this terminal. Okay, so micro didn't leave. Why? Why isn't Python and has a bit, I couldn't understand the front page of GitHub README, so I kind of skipped it, but maybe we should still try it. Yep. Okay, this is something new. Checking for inner conflicts. Is this a conflict? Remove make dependencies after install. Is this a conflict or not? I had one time with Gentoo very bad experience trying to manage Perl installations, and I got myself to the hell where I couldn't resolve the dependency cycle any longer, and it all got stuck, so I had to distro hop again. So I'm a bit afraid of conflicts. Neovim Helix HX. There's another editor. I think it's in Rust. I like its modular structure, at least the directories in the GitHub. Yeah, but modular structure and directories at GitHub don't really give you capabilities to open big files. But the AMP and Helix editors, they open the stuff quite fast. When Neovim was kind of, it was very moderately bumping up memory usage. Okay, so Helix managed to receive SIGINT channel or SIGINT signal and quit. That is very nice. I think it's a plus overall. If we can't read a big file, we can at least finish our session. So Xi, I'm not sure what to install on Xi because, or Xi, how they tell it should be pronounced, but I will say Xi because it is natively the main installation is Cocoa on Mac OS, and I will need to find a third-party front end to use it on Linux. QEdit, it is also not a very complete. It is from one person on Discord in the Zig. I just have it here to have a look. So in future I could maybe also get some ideas from its implementation. And I think that is all for now. Yeah, we made some progress. We displayed file and lines, used new curses, and we tried some fun with this 46 gigabyte file. So yeah, thanks for watching. See you later in coding sessions for an epic quest to write a text editor, which is going to be hopefully superior, but probably not. We'll see. Bye.